Hello, my name is Florian, and as part of the Energy Transition Lab, I'm here to tell you a little bit about my research that I've been doing for my thesis. Yeah, it's the Energy Transition Lab, and as we all know, the energy transition is something that is a massive operation and also insanely complicated. The energy system encapsulates so many aspects of our world that we cannot help but use a lot of tricks to make it just a little bit more easier to design policy for it. So one of the main things that we do is we use models to model a part of the energy system, and then we create some sort of policy intervention, and then we see how that changes things and what the costs of that would be and how much carbon emissions we would get out of the atmosphere. So that is modeling. Now, I am working with a model that I did not develop myself. It's called Sequoia, and it was developed by CE Delft, a bureau in Delft. And this model, it models the Netherlands, it models the houses and all the other buildings in the Netherlands, and it looks at their energy demand, specifically for heating the buildings. At one point, we're going to be switching away from natural gas, and we need some sustainable options to stop emitting emissions. So the options that we have actually are not that limited. There's a lot of things that we can do, a lot of systems that we can have for our homes to implement, but we also need to know how much all of those systems are going to cost, if they're feasible at all, if we have enough resources to use those systems. And that's what the model does. It looks at all the buildings and it aggregates those to a neighborhood, and then for that neighborhood it can calculate dozens of different options. For example, heat nets based on some industrial waste heat, or it can calculate what it would cost for heat pumps to be implemented, what that would do with the electricity grid. Dozens of options are evaluated, and that in itself is like a very useful, interesting outcome, because for any neighborhood you can see, oh, these are the options and these are the cheapest options, so that's probably what my building is going to get. So that's one part of the model, but I'm not actually, with my research, that much interested in that part of the model, the outcome. I am looking more at the model itself, because it's very big, the model. It's been developed over the course of, I think, about 10 years, and to be able to calculate all those options for the entirety of the Netherlands, it's going to be a bit complicated. But because of that, it's not that easy to sort of know what's going on in the model. We don't really one-to-one know why a certain outcome rolls out of the model. We sort of have a feel for it because we have the mathematical equations which are in the model. But if one input variable, for example, the electricity price, goes up by just a little bit, so the assumption that we put in for the electricity price is not correct, well, that can change the model outcome. And that's important for policymakers, because you need any and all decisions to be made for such big investments to change these systems. You need those decisions to be robust. And that's why I'm looking at the model. I'm basically answering the question, what is the effect of a given input parameter on the model outcome? And that's sort of a small single question, but you can infer like a lot of interesting information from it. You can spot mistakes in the model. If you can see that some input-output relationships are broken. You can also find those parameters which are super important, but are also not that well modeled. For example, again, that electricity price, if the assumption that we took from that is, I don't know, 10 years old, it's not, but say it is, then we should probably look at that again, and also maybe play with that a little bit more in giving recommendations based on the model. And so that's another thing. And also just the relative importance, or not importance, but prevalence of certain options over other options as a recommendation out of the model. Those can be very valuable insights for not just the people at, say, Delft, but also the people in the municipalities that have to make decisions for and with residents, because it is going to cost a lot of money, and we're not at a point yet where we really know what the best options are going to be. And I find that personally very interesting, and I'm kind of excited to be contributing to the energy transition in this way, just to do my little part.